Oh, dear. Wasn't that a great time to be alive? I wish I could go read about it. Well, I'd like to get our panelists up to have a little bit of a round table, even though it's a rectangular table, and then we'll open it up to questions. So if we can have our panelists seated, we can try and shed some light on some of the questions that I know are still unanswered. Let's see. I guess maybe we'll go in the same order. Glenn, let me start with you. You know, one of the constants over the years has been a kind of a battle about what the justification for the science missions have been, and planetary, of course, is only one subset of that. But you know, if you of course have been pointing out that we misuse the word precursors, or we miss the nuances in the word precursors, and so I'll just throw out what may be a simplistic interpretation of the past events, which says that the planetary program is sort of like the remora that latches onto the human spaceflight shark, and only makes a living as long as that shark is healthy. Has your research given you a different perspective of how planetary fits into the broader picture of the space program?
Wow, that's a big question to start with.
We don't mess around here.
No, yeah, seriously. No, I think, historians will say that there's three general historical justifications for spaceflight. There's the von Braun nationalistic approach, plant the flag, Gerard O'Neill's space settlement vision, and Carl Sagan belief that just understanding the solar system evokes a sense of wonder that cannot be replicated anywhere, and by studying anything else. And I think to a degree it's very possible to continue to pursue a planetary science program for those awe moments when something really spectacular is discovered. That said, it's hard to build a business case on that, and sometimes within planetary exploration that's required. And there are a lot of people who believe that settling the space system, either because of what's happening here on Earth or because ultimately humans just want to go out there and step foot on the moon, is a worthwhile goal. And I think planetary science and human will always be intertwined as long as there are people here on Earth. But definitely the urge to human settlement of the solar system is something that's very compelling, and I think we need to recognize that as a factor in understanding the course of planetary exploration.
Anybody else want to weigh in on that rather large chunk of reasoning and questioning that we've got on the table? Scott looks absolutely, I can't tell if you're in a trance from that question or...
I'm dazzled by the last 2 days.
You're numbed.
Yeah, no, one thing that we haven't talked about at all with respect to the planetary program is that someone observed it was an invention of NASA. Every other element has other agencies that are involved. In the earth science arena, there are many agencies that are involved. So on the one hand, that makes planetary sort of vulnerable, because one agency decides if it comes or goes. On the other hand, I would argue to Jim's boss and boss's bosses that it means you have a special stewardship responsibility as well, because the return on investment as inspiration to the world is just staggering. Some people have commented on this tangentially. I know when I have a good friend who's a Spanish physicist, Juan Perez Mercader, who's started the Astrobiology Institute in Madrid. And when Mars Polar Lander and Mars Climate Orbiter disappeared, he was really shaken. He said, when NASA doesn't do well, the entire world feels bad. So I think that we somehow, through the planetary program, bring this sense of inspiration and uplift to the rest of the world.
That's certainly, I don't think anybody would argue with that, and yet we've heard so many times over the last 2 days, and particularly yesterday morning's discussions of budget, that when the going gets tough, it becomes very clear that of the space science pursuits of NASA, planetary is low man on the totem pole. And how do we grapple with that? How do we reconcile that? How do we change that? Does anybody want to weigh in on that? Is it a matter of making the case better?
Yeah.
Amy?
Yeah, I mean, I think this time around, it really wasn't so much low man on the totem pole there wasn't any sort of prejudice associated with being prejudiced against the planetary program. I think it's a matter of timing in this case. With respect, I think we're alluding to the 21% budget cut in the FY13 budget most recently. And I think that was mostly a product of the fact that NASA and the White House and Congress have a lot of constituencies that they need to satisfy in terms of the budget, and across human spaceflight, aeronautics, space science, of course, and so there's sort of a general understanding that you've got allocations, sort of a box, if you will, and that generally speaking will go to space science, and then within space science you have the contention of planetary science, astrophysics, heliophysics, and Earth sciences in the Science Mission Directorate now as well. And I think this time around what it was there is one massive space science mission, not faster, better, cheaper, the James Webb Space Telescope, which is consuming a lot of budget, certainly, and I think that kind of mission is generally kind of scary to folks in the White House and in OMB. I can speak from that experience, and and fear to have to in place a mission like that. You get stuck. I mean, in terms of kind of passing, running into the overruns and such. And also, there's generally a concern about leaving kind of what you leave for future administrations. Whether you buy into that logic or not is another matter, or agree with that rationale. But that kind of sense sometimes exists.
Well, let me stay with you for a second here, because one of the things that I remember, that one of my favorite anecdotes from the faster, better, cheaper era came from Tony Spear, who was the project manager on the Mars Pathfinder lander. And, they had this small, young, eager skunkworks type team at JPL that could really get in and reinvent how you land on Mars. And it was all very exciting. And of course, we know how it turned out. It was wonderfully successful. But, Tony told me, here, on the one hand, you had Dan Golden out in public, boasting that he was telling his people to take risks, and that was a good thing. And in private, he was telling Tony Spear, don't you dare fail or I'll shoot you on the JPL Mall. Now, my question is, out of that, and I'm interested in your perspective also as former OMB denizen, what is the tolerance or lack of tolerance for mistakes, whether they are mistakes in costing a mission budget or whether they're mistakes in performance? Can you talk about what you saw from both sides of the fence?
With respect to performance, let me think about this. I think that the crowd, I mean, there are rational people. I mean, I know the decisions don't come across as rational all the time, and they're not rationally constructed.
Seems to be a lot of laughter going on in the room.
But there
Not sure what to make of that.
Yes, exactly. But there are actually people there who very much care about the space program. In fact, I mean, it may be a little known secret, but most of the folks who are at the Office of Management and Budget and at the Office of Science and Technology Policy are actually there because they believe in, if not have a background, actually, they pretty much all have a background and higher degrees in these fields. So I mean, there is a passion there, and I think there is an understanding in terms of when things don't perform, that these things happen. Usually, though, there is some sort of there's some sort of response, and that response is, usually it's actually more money comes, when you have a performance issue. No one wants to create, or no one wants to recreate the failures of the past, and so either a mission may be reflown, as was talked about with the Orbiting Carbon Observatory, that's an earth science example, or you see very, sort of major changes with respect to Columbia, for example, and it inspiring the vision for space exploration. So I'm kind of drawing experiences that aren't necessarily solar system exploration specific, but giving you the landscape of attitude about NASA. In terms of cost, so if the missions fail in terms of cost, those are looked at, I think, really on a case-by-case basis. Sometimes the answer with respect to James Webb was to continue to fund it. But part of that was driven by consulting with the science community and also the view of Barbara Mikulski and others in the Congress. So those decisions aren't unilaterally made by OMB. The final president's budget goes out, but they're driven by the influences, I would say, of other actors too.
Scott, and this is also a question for Chaz, because both of you have described enterprises which in some ways are a leap of faith, right? Scott, the Mars program was predicated on follow the water, and you found the water, but you haven't found life yet, and there's no guarantee that even after a very careful program of reducing the technological risk of a sample return and choosing the best possible site you can, there's no guarantee that it'll be in that 2 kilograms or whatever it is that comes back. And Chaz, you've been talking about a very optimistic vision of what we might discover on exoplanets that would certainly capture the world's imagination. But what about the risk of promising something that you maybe can't deliver? Each of you would like to weigh in on that with your respective...
I think the biggest challenge we have with exoplanets is the exciting goal is clearly to find life in the atmospheres of some habitable Earth-like planet. That is among the hardest technological things I can conceive of. We've laid out you need an 8-meter telescope, well, maybe it's a 6-meter telescope, maybe it's an occulter, maybe it's this, maybe it's that. It will, whatever it is, it will be a Webb-class mission to do that. And it is a hugely demanding physics experiment, first of all, and I think we've made good progress on showing we can do the physics of it, but it will be a very complicated space system that has to do that. And, one should dream impossible and great things, and we are doing it, but it's going to be a very tough experiment. And if the nearest Earth, when we finally find this parameter that I've called eta sub Earth, the fraction of stars that have an Earth-like planet in the habitable zone, is too small, so we have to look further away than Alpha Centauri B, for example. If we have to look to 25 parsecs, 75 light years and not 2 or 3 light years, we may not be able to accomplish that goal. It looks as though the eta sub Earth, the fraction of stars with habitable zone planets, may be as large as 5, 10, 15%. We get the statistics from Kepler, some of the radial velocity work, and so on. If they're close enough, we can do it. If not, it may simply be unattainable. And we'll just have to wait for Jill Carter's daughter to hook up to the internet.
Scientific risk and technological risk are the two things that you have to mitigate, have to understand and mitigate before you embark on an enterprise that is a decade-long series of missions, for example, with the Mars program, and the next decade that we hope comes. So let me talk a little bit about 2 pieces of scientific risk. One was the Viking effect, where there was an instrument that everyone believed if you took it there, reached out, because Organic material was ubiquitous. You grabbed up the soil, you put it in the chemistry set, you added water, and voila, you would see the isotopes of carbon, and you would have the fingerprints of life. And of course, that didn't happen. So in the wake of that, what turned out to be a huge scientific risk.
Not, if I can just throw in for people that aren't familiar with the history, not only did they not find organics, the only way they could interpret the biology results was through the presence of highly reactive compounds like peroxides that would mean that the soil was actually hostile to organics.
Yes, correct. And so in the wake of this, taking this scientific risk, although they probably didn't realize it at the time, the focus of the Mars program and, in fact, astrobiology and a bunch of other disciplines moved from that hit the home run and discover life in one fell swoop to understand the habitable environment, understand the range of habitability for living systems. And of course, in astrobiology, that gave rise to understanding extremophiles and a range of living systems that nobody expected 15 or 20 years ago. So that was one step in mitigating the scientific risk toward finding life on Mars, is looking for habitable environments, either past or present, rather than that thing that is so difficult to do, which is to define life and create an instrument that will go and actually detect it. Second piece of scientific risk was in large part why I canceled the existing Mars sample return program in 2000. You know, there were plenty of cost reasons. It was going to be done for $1.98 and, you know, leaps of faith on the technologies that I showed you and so forth. But the main reason I canceled it was the scientific risk was simply too high. We had a room of this size with about 80 or 90 of the best scientists, engineers, executives in the planetary program we could find, and I said, who can tell me where to go to get a sample that is worth, I think the cost was then $3 billion, and there was no crisp answer, and the best that you got was, well, a grab sample and you'd find basalt. Well, that's not worth it. So as a result of what clearly was a major scientific risk, that was set aside, and the decade of understanding Mars as a system and looking for habitable environments came in its place. I think now we have, as a result of that effort, retired a significant amount of scientific risk. We have retired, I would say, 3 of the 4 technological risks, and as a consequence, I would argue to our friends at OMB, we are ready to do this, and it is an attainable goal.
What do you think, Amy? Has he got his elevator pitch down to a point where OMB will go for it?
It's attainable for the price, I guess, is again, the,
I think is within reach.
is the
The price is within reach, Scott? Okay.
Yeah.
All right. Well, at this juncture, since we've solved the problems of the world, why don't we open it up to questions? And we have the traveling microphone, and Mikhail, please.
Well, thank you. Actually, I have 2 questions, one to Scott, one to Chess. Scott, just according to the follow the water strategy you described, very wise, but it seems to me it's not completely well. Just embrace all possibilities. We are trying to look for signs of life, both, you know, extant or extinct life, just on the surface. But surface is so oxidizing environment on Mars, and possibly oxidizing go quite deep. So there are concepts similar to what we have on the Earth, deep-seated biosphere. Deep-seated, it just was discovered on the planet Earth only at the end of last century. And possibly it's even better environment for the microbes, for the primitive life on Mars. And it seems to me just it should be in the program one specific segment we specifically targeted to this idea.
Scott, can you summarize your understanding of the question before you answer it?
Yes. So this is a very good question, which is the follow the water. The last decade of Mars missions which are characterized by this very simple phrase, have been looking for habitats that might preserve the biosignatures of extinct life. It really has not been geared toward extant life at all. So the question is, if you go down that path, isn't there a whole extra path where you might go under the surface, particularly at least 2 meters down, under where things have been gardened and irradiated, and find...
Could be a few kilometers.
Could be a few kilometers. And so this is a very tantalizing possibility. We may have evidence that periodically plugs of ice are melted and we get brine flows. It could be water is very near the surface. But drilling kilometers autonomously is a technological challenge we don't have a good answer for right now.
And in fact, it's been used as a justification for sending humans.
That's
That-
why I
that
put
kind of-
that onto my last chart.
Yes.
It was the colonists who went down, Bruce Willis and the drilling guys
There you go.
were there, going down, because maybe that's what it takes to, or either that, or you have to go into caves. You need cavers.
Yeah,
You
speed
anticipate
lumpers.
just 25 years from now to find something similar to exoplanet.
But I think the argument for extinct life, if you find the right types of sedimentary layers and minerals, that is the most likely strata to have preserved the extinct fingerprints of life. And that's what this whole last decade has been about.
Yeah, we really should make it clear that there are really two potential presents under the Christmas tree, and one is extinct life, which I think people may have hopes of, and then there's the question of existing life, which is a whole other level of investigation, and
Well, now let's wait for the methane results.
yeah.
And if possible, the second one. Chess. Again, the strategy to find as much as possible Earth-like planets and the science for life, obvious things, and different instruments and different facilities are developed. You mentioned about that. But what is kind of rationale you would propose, being just in charge completely of the overall program? I mean, ground-based facilities, space segment, certainly you would say both, but it's impossible to embrace everything, But we have, for example, already square kilometer array to be deployed very soon. It's a powerful radio astronomy instruments in the southern hemisphere, Australia, South Africa, okay? And not saying about so powerful optical telescopes under development right now. And also we have James Webb telescope, we have Darwin and many others. So what do you think? What kind of rationale? What kind of the strategy? Because it will be very much, just money-taking process. And I do not think that everyone in the community, both in planetary and astrophysical community, will enjoy it or about that.
Well, I think one of the things we learned painfully over the last decade is that whatever facilities we develop do have to be multi-purpose. So, for example, I think we originally proposed to do an infrared interferometer that might have been the simplest thing to go and find the infrared emission from from an Earth, sitting an astronomical unit away from his host star. That was of relatively little interest to the rest of the astrophysical community. So I think right now the astrophysics community would be very interested in a large visible light telescope that would be the next big step beyond James Webb, which of course is an infrared telescope. And that large optical telescope, optical UV, would have instruments on it capable of getting down to the 10 to the minus 10 contrast level that you would need for some observing modes, but then would also do spectra of Z of whatever, galaxies were also obtainable, so that you get a convergence of desire by a fairly broad set of people in the astronomy community. You would also have interest from the exoplanet community, presumably the planetary community would be interested in getting spectra of giant planets, even potentially down to Earth-like planets. So I think that's the challenge, is to come up with a mission that could do that. I haven't heard a convincing argument that lets you do the spectroscopy of a habitable planet through the Earth's atmosphere. I mean, the 30 and 40 meter telescopes that will probably be built, either in the US or in Europe over the next 10 to 15 years, the challenge of working through the Earth's atmosphere is simply too great to get you to these extreme contrast ratios that you need. And that probably requires being in space. The proponents for those telescopes argue they might be able to do it. Pretty skeptical. Of course, they'll say, gee, we're pretty skeptical that you can do it in space either, and it's a tough problem. I think space simply gives you an advantage of getting above the atmosphere that's very hard to negate. So I think that's where we're going to go, and it may take 20, 25 years to get there. I put it in 2040. Maybe I was being pessimistic. Maybe I was being optimistic. We'll have to see. But it will be challenging technologically, and that's because the physics dictates what you have to do. If Alpha Cent B, planets C, D, and E are in the habitable zone, that helps enormously. Then you're talking nearly an order of magnitude simplification in the problem, just because the planet is that much further away from its host star, and that's what drives the difficulty.
Okay.
This question is probably for Amy, but I'm sure Scott and Chaz and others will have an opinion on it as well. We've talked a lot over the last few days about ebb and flow of budget, ebb and flow of the pace of missions, and ebb and flow of success. But we haven't talked about one of the factors that could be a contributor and that is recognized in some other areas as a contributing factor, and that is the training of the continuity and training of the workforce. In the lost decade, we had many less engineers working on planetary spacecraft and developing the systems. And did that contribute to what we did achieve and didn't achieve in the 1990s? And in fact, is the success, the remarkable success of the last decade, in part traceable to the success of being able to consistently hand off the responsibilities for development, engineering, and operations from one well-trained group to the next well-trained group? Your thought? It's a topic we haven't talked about at all in the last 2 days.
Talked about, and I have no idea in terms of tracing, the particular strains that you're talking about and the relations.
Okay, but Chaz and Scott both think it's critical.
Yeah, I would defer to these.
So let me give you one real clear-cut example. When I was in Pasadena before we gathered at JPL for the Curiosity landing, I was down at the Planet Fest event, and I ran into Rob Manning, of course, the chief engineer for Mars Science Lab Curiosity, and I've known Rob since 1993 or so. And I said, "So, Rob, how's it going?" He said, "Enjoy the show. It's going to work." Now, I realized that, he was pumped up about the whole thing, but I said, "So, why?" He said, "Look, we have tested this thing. We have years and years of testing. We've tested overlapping things in the case that we can't get the exact environmental condition. We've done every conceivable failure mode and so forth." And he said, "We're highly confident this will work." To that explanation, I will add that Rob Manning and Cookie and the others started with Tony Spear on Pathfinder in 1993. They went through Pathfinder, they went through Spirit, Opportunity, Phoenix. This was their 5th landing on Mars, and you have a cadre of people who have learned all those tools and techniques, And the numbers I showed you to do the caching rover, that one of the reasons that you can say that's a good number and is so low is because you're counting on those people being there. If
Exactly.
you delay this, and this is what I tell to my OMB OSTP people, they don't believe it, but if you delay this by 5 to 10 years, these folks have to make a living. They'll go somewhere else. You won't have this expertise.
It's something that we understand in human space flight, and it's been talked about a lot. It's been talked about a lot in the launch vehicle development community, where that was lost and is now being rebuilt, and it bears here as well on
It's
planetary.
true in astrophysics, it's true, you know,
Yeah.
at JPL in all different areas, you know, as
Well-
these giant missions suck up all the oxygen, you lose people in other parts of the program, and it's very discouraging to have somebody land on Curiosity and say, well, gee, I need a charge number starting next week because I just finished EDL. I wonder where else I can go. And they'll go somewhere, and you lose the best people first.
Well, in fact, it was part of the justification for the NASA Lunar Science Institute was that we had not done any lunar science in quite some time, and we needed to train a whole new cadre of lunar scientists.
That seems to be working very well. And, you know, I think one thing that came very clear in this conference is the enormous perspective that some of the people who have been in the space science community for so long bring to it. I mean, they're not just building spacecraft, they're building instruments, they're fighting budget battles, they're developing planetary models, they're archiving the data, they're training people to follow after them. And it's just been remarkable to hear from some of the people who have been involved for so long about what sort of experience they have gained.
Okay, Greg?
This dialogue is a perfect intro to the question that I wanted to put to Amy, which was why I stood up. And it's not to put you on the spot, but you did comment that the folks at OMB and upper reaches of NASA who made this decision concerning the fiscal 13 budget are smart people, intelligent, well-educated, and of course we know that to be the case because we know them ourselves. The question that I have for you has two parts. Do they understand the implications of standing down for 5 or 6 years and the loss of this workforce? And if so, what does that tell us about their true intentions? If they don't understand the implications of standing down for 5 or 6 years, why not? And what can we do to help them understand this? And again, not to put
Not
you
to
on
put
the
me on
spot,
the
because
spot,
you
not
weren't
to put me
there
on the
and you
spot.
didn't do all
Thanks
that.
for-
No pressure at all, Amy.
Caveating that. Yes, I mean, so to answer the yes/no part of it, yes, they do understand the implications of standing down. And it's a real problem. I mean, and, you know, I think everybody there would like to see, you know, everybody at, you know, at OMB, oh, I shouldn't say everybody, but, no, I hate to you know, but on the whole, I mean, again, the folks there who are reviewing the NASA budgets are supporters and you know, want to see NASA succeed and do great things, as do so many people. That, you know, the challenge is faced, though, that there is so much content there, and choices have to be made. There's a lot of instances where, you know, there's issues of these standing down, and if we stand down, then we're not going to be able to do X and Y. And at a certain point, you can be propping up armies, if you will, and I don't mean to say, I mean, it doesn't sound, you know, totally diplomatic to say that, but just, and keeping folks going for the sake of preserving a capability that you're going to use in 10 years. I mean, we could say that across, you know, various disciplines, and if we're constantly doing that, you know, the question is where's the budget for the content? I don't have an easy solution. Obviously, the people there don't either. And I mean, I would love to you know, have more dialogue, you know, with the community about, you know, what solutions might be possible to mitigate this. Is there a way to cross-train people? And I mean, and some of this goes back to, you know, prior to people enrolling in the workforce, but is there a way, I mean, as you're, you know, in school and you're in an engineering field, and you know, that you become cross-disciplinary and that you're kind of prepared for these sorts of shifts and changes to have to occur. And then there's the question of how you preserve the institutional knowledge. I mean, that is a big one. But I mean, these are two things I think we have to conquer, and not just see budget and carrying of people as the solution, but as, I mean, that there are other things we might do to preserve the.
Well, it kind of comes down to basic economics. The people who made it possible to make the progress that Scott showed on one of his charts. He picked one example of the landing air ellipse and how that has shrunk over generations. Has taken a constant effort on the part of now 2 generations, and none of these people studied how to do that in school. There's no field for that. And it's such a niche area that there never will be a field for that unless there's a job out there for them to go to.
It's so
So
specialized.
if you don't, it is so specialized, and yet it is absolutely enabling, just like the deep space navigators who navigate the Cassini spacecraft. Every single day, they are changing the trajectory in order to be able to do those flybys. That's the only market for what they do. So if indeed the folks over at OMB do understand that this means losing that, that's tantamount to saying that they have decided that it's okay to cede this area.
Okay, I'm not sure we're going to solve this one.
But it is, I mean, it's a zero-sum game, so it's
Yeah.
a choice. It's a
Okay.
choice. Everyone's
Thanks.
choice. Yeah.
Janet?
Thanks so much for a great panel. One of the things that struck me that cuts across all the talks is a particular thing that is very powerful. And more powerful, I think, than RTGs, and more powerful perhaps than OMB. And that's the power of talk, or specifically what academics would call discourse, and that is particular kinds of ways of talking that are shared by different members of different communities. And I'm thinking of several of these because they're important, especially in Amy's paper, which was brilliant, articulates exactly how that talk works in a network. So things like faster, better, cheaper, or follow the water. These are things that we all know. They're common ways of talking. They are discourse, right? But they're really powerful and important because they pull together actors in that network in a particular kind of way, and they justify activity in that network. They're also important because you can have anticipatory talk. You can have future discourse, right? Whether it's the discourse of the Precursor mission, or, as I would argue, the discourse of Mars sample return, right? These are particular things that haven't happened yet, but we're talking about them in a particular kind of way to pull those people into some kind of alignment. And thirdly, I think it's important to pick up on something that Glenn mentioned at the beginning of his paper, which is that the ways in who gets to tell the stories actually betrays a particular kind of politics, right? That, you know, that JPL is such a strong actor and not necessarily Ames or Johns Hopkins, et cetera, right? And that's the result of kinds of ways of talking in the network. And I want to take advantage of the fact that we have both historians and practitioners in this room to actually have a conversation about what it means to talk this way. Because I think for historians, it's really important for us to not take that discourse as the explanation, but as the thing that needs to be explained. And I'm very curious as to how we might do that. I think the Sociotechnical network is a great way of getting at that, but I'd be very curious to hear about that from your perspective. And then for many of the actors in this room who've played such an important role in pulling these missions together, in formulating phrases that have been so meaningful and powerful, what is your role, do you think, in putting these phrases together and mobilizing the network? What does it take to get those words to travel? And not just travel to Washington, but travel to Mars and to Saturn. So I'd love to just open up to the panel an opportunity to talk about what discourse means, what it means to talk, where these different kinds of phrases and expressions come from, and how and where they move, and what gives them the power.
Anybody want to take a shot at that?
You know, Kurt Vonnegut said, any physicist who can't explain what he's doing to a 9-year-old is a fraud. So you have to be able to intellectualize what you're doing, why you're doing it, and explain it to a broad range of people. 9-year-olds, Congress people, administrators, peer scientists. I mean, you have to... no comment. I mean, you have to be able to have a discussion at a very high level with a cosmologist whose mission you may be saying, well, gee, I want to delay your mission by a decade so that I can do my exoplanet, or, you know, explain to a congressperson that there is a reason why it's interesting to go find life on some, you know, planet that's hundreds of light years away, and have them say, yeah, that's a good thing to spend money on, even if it's not going to put a bridge in my district.
I call it haiku for science. You need to explain what you're doing in 17 syllables. And that was the power of Follow the Water. And if somebody wanted to know more, you could go on for hours. If they were satisfied with a simple explanation that is literally the elevator pitch, then that's fine too. Words have immense power, and one of my quibbles with the characterization of Mars sample return is that is a technique. The real goal is understanding habitability and present or past life on Mars. It just so happens this technique is the one that the community agrees is the most powerful technique for making a huge step in understanding. And what's occurred is that the technique has been characterized as the end goal. The end goal is understanding the presence or absence of life on Mars.
Okay, I think we've got time for one more.
What's the role of new up-and-coming participants? China, maybe India, Brazil? Where do they fit into everything that's going on?
Well, let me just start sort of in response to Janet's question as well. Where they fit in terms of understanding space policy is they're a different group with different motivations, different social technical networks like Amy was talking about. We spent a lot of time talking about NASA administrators, Congress, what is involved in making them understand the goals of space science, and in different communities there's different ways of talking. Part of the reason we do history is so that we can look at, stepping into the same river at different times. Space science looked different in the 1960s than it did in the 1990s. Part of the role that historians play in a conference like this and talking to policymakers, there is this goal to simplify and focus on terms: Mars sample return, faster, better, cheaper, precursor, exoplanet exploration. But historians have an obligation to sort of go back and unpack what those words actually meant and how they actually were implemented. I mean, Mike Neufeld gave a very interesting, in some ways very chaotic, paper about the explanation of the invention of faster, better, cheaper, and how it really happened. Eric Conway likewise gave a very interesting paper about the image of Mars sample return, suggesting that in these periods where some people can look back and see a path from where we were to the present, and people working in those era could have come up with a very simple explanation for how things happened. There actually was a fair amount of contest, a lot of people with different missions trying to figure out which way to go. And I think we also need to understand, that NASA, it's not, we live in an age over the past 50 years where NASA has been the big player. There are missions like exoplanet exploration, Mars sample return, that no other type of organization can do. But NASA works within a much larger context that includes the international partners, universities, commercial firms that work on subcontractor, commercial firms that have other commercial aspirations. And yes, figuring out how all these different people can talk is one thing that I found most valuable about this conference. But that's not a direct response to your question about the international partners. Maybe there's another.
The new international partners, say the Chinese, are slowly becoming integrated into the astronomical community, first in the ground-based. They'll probably be a participant in one of these large ground-based telescopes. The TMT project is likely to have Chinese participation, maybe also Indian participation. I think as you build up the interpersonal and scientific collaborations, assuming the politics works out favorably over the next 10 to 20 years, you may well have China being as well integrated into what we're doing as we now have with the Europeans. Could not go that way, but certainly there's talk among astronomers that China would be an obvious place to find support for our ground-based aspirations. In 10 or 20 years, maybe for the space-based ones as well. They certainly have an active space program. It's not yet integrated into the NASA or European world yet, anti-integrated, but that can change.
Let me ask Scott, we saw on Mikhail's slides, I'm sure you noticed, and I don't know what your reaction was, and you probably knew this, the Russians are planning a Mars sample return mission for about the same time period that we would be. And having grown up at a time when many people were asking, why are we competing with the Russians and going to the moon, why aren't we cooperating? And of course, we've seen many iterations of that. At this point, does it make sense to talk about a joint sample return mission and spread out the risk, spread out the cost?
Well, the ExoMars collaboration was intended to be the first step toward a NASA-ESA collaboration on sample return for exactly the reasons you mentioned, which was to spread out the cost, diffuse the risk. Right now, the international collaboration in that particular arena is low. For a variety of reasons, I think it will come back. I think certainly the human exploration of deep space is going to be an international endeavor. In somewhat direct response to your question, you can ask the question, why explore space? And there's an hour lecture I give that has the 6 reasons I've collected. But the first of those for nation states is that it's a significant badge of accomplishment. You know, there's only the Soviet Union and the United States that have had the independent ability to put humans into even low Earth orbit. The Chinese are following the Gemini Apollo playbook, and it is for them a badge of accomplishment, and as far as I can tell, it is for India as well. There are many, many applications of Earth orbiting spacecraft for disaster relief and so forth, but where you ask the question of, you know, why put people in space, you cannot ignore the national interest part, and I think that's what drives some nation states to want to do that in the first place.
Okay, Torrance, you want to make a point?
I just wanted to make a very brief pitch for optimism. In the context of the time that all of this takes. 1610, Galileo discovered the solar system effectively. By 1710, Isaac Newton had it figured out how it worked. We're still ringing changes on the restricted three-body problems with all of these trajectories we're talking about. We're talking about a field that's half that length of time long. In my own terms, I've been working on Cassini one way or the other for half the time since the launch of Explorer 1. Now, it may mean I'm old, but it also means this field is young. And during that time, we've gone from 0 exoplanets to over 800, and I suspect that Chaz's future history is actually conservative.
I can't think of a better note on which to end our panel. Thank you, Torrance, and thanks to everybody on the panel and to the audience.
Well, gentlemen and ladies, it's time to close our symposium. I would like to think that we have learned a great deal during our 2 days here. I will point to 2 things that I think are very valuable for us as we think about this particular conference and as we go forward. The first one is the interplay of historians and other social scientists with engineers, program managers, scientists, I think has been a very rewarding experience and quite synergistic. And so I hope that we take that away as something to pursue in the future when we think about these sorts of issues. Secondly, one of the things that we have learned through the 2 days is how much we don't know. There has been more questions raised than there have been answers offered. And that's to the good as well. The history of planetary science, of solar system exploration, is a very rich one, and I hope that we will continue to pursue it into the future. I know the historians we're going to mobilize to try to do so, and we're going to be calling upon all of you who are practitioners to help us. As we close, the first thing I would like to do is just to acknowledge our sponsors, NASA, JPL, the Smithsonian, Lockheed Martin, for all of your excellent support for the activities that we've done for the last 2 days. So could we have a round of applause? And could we also have a round of applause for all of the presenters and all of the people that made this possible? All right, with that, I will gavel. I declare our sessions closed.